Humanity has crossed the point of no return on AI, but we haven't arrived anywhere yet. Welcome to the Post-Liminal Show. Honest conversations about living between the old world and whatever comes next. I'm Nick, co-founder and CTO at Whitney AI. I have a background in RL and post-training.
And my name is Kevin Miao. I'm the CEO and founder of Brile, where we automate research engineering and allow companies to own their own intelligence stack. So we thought very, very long about the name Postliminal. We were very, very curious about where the frontier is bringing us. This kind of brings me back to when I was at a party around 3 weeks ago. I think it was right after GDC, the game development event. And I met the CEO of Handshake, and his name is Garrett.
Mm-hmm.
And he came to me and he was like, hey, my wife has a question for you. With AI moving so fast and me running a data labeling business, do you think humans, will still be employed? Like, will they still be labeling? Do we still need human data? And I think it's such an interesting question. The current demand is just exploding, right? I think there's just so many companies that are literally just paying millions or not billions of dollars of spending it on data environments. But what is going on here in this space? Like, how do you see this?
I mean, first, I think you need to understand why the business is the way that it is. I don't know, to the onlooker, it's like, well, why is human label data even necessary to begin with? And it's basically in the process of improving AI, you're going to show it increasingly difficult problems, and usually it helps to show it solutions, and you're going to have it try to solve the problem, and you can kind of grade the solution, and that's how you improve the AI. You're effectively teaching it kind of like you would a student in class on various domains. And so Handshake and Mercury, these companies that you're talking about, what they're doing is they're hiring these armies of humans to curate those problems and answer those problems to teach the AI. But the thing that I think is interesting about that is that as dissatisfying as this may seem, and it's probably a little bit controversial, but I would say that the range of human knowledge is limited,
Mm-hmm.
right? And so I do kind of view Handshake and Mercer and companies like those as an inexhaustible resource. And if I were, say, the CEO of either of those companies, I would probably need to have a plan in mind for what happens when our utility has kind of been exhausted.
I think it's very, very interesting to think about this, right? We're saying is okay, we're using human labor to teach AI to do things. When we look at, for a couple of years ago, labeling data was a lot more easy, right? The tasks were a lot more easy. It was a lot more focused on vibes. You saw people voting for the responses. And I was at a lecture with John Schulman too, and he was saying is that we're increasingly moving towards expert labels, right? Back in the days, anyone could label these responses. And now we're looking for very, very specific areas. We're looking for accountants and doctors, and we're looking for professors. I saw a post on LinkedIn from Recor where they're hiring a professor to label their data. And I think something that does become very interesting, what you mentioned, is okay, at some point, we will need smarter and smarter people because the models are becoming better and better. And the question then becomes, what is going to happen next, right? That's probably a longer projection, but how do you feel about this?
I think that's a really interesting observation, first of all. If you look at the hiring, profile of the people that those companies have targeted, it probably began with students. I went to a university. Handshake actually began as a university recruitment company, right? Until they pivoted to this data labeling space and became Handshake AI, which for their business was great. But I remember getting some of the preliminary emails hey, we're looking for computer science students who can solve software problems, right? And that can kind of become the training data for the AI. But now it's kind of you're saying, we're looking for professors and we're looking for experts. It's Terrence Tao that's working with OpenAI, let's say, trying to collaborate on some of those Erdos problems. And once we no longer need that current wave, there is this very pressing question of what comes next. And I think that that's an area of active research now, because now the AI researchers are realizing that that initial kind of easier source of reliable data is kind of starting to phase out. And so as we start to exceed human intelligence and train AI to go beyond us and explore unsolved questions and whatnot, that is where we're starting to think about things. And I think self-improving agents is kind of like one domain in which that is relevant.
Yeah, I think it's such a cool notion of like self-improving agents. I've seen so many companies starting to promote in this space. There's researchers that talk about recursive self-improvement.
Hmm.
We have seen that Prime Intellect, they actually started releasing this new product line. I think they call it self-improving agents. We have Raindrop, which is an observability tool that allows people to automatically patch, their prompt given like any error that is going on. And I think it's such an interesting space. But for me too, I feel like it feels, years away until we get there, right? I think like what is self-improvement, right? I think it's not just patching things, but like what is, self-improving agents? Is it a buzzword? Like, do you believe in this space? Yeah.
That's super interesting. I think there's a lot of things that can go into it. Um, at the end of the day, like in orthodox training, you have a set of problems and you have a set of answers and you have like predefined graders, right? And so like each of those is kind of a constraint, and there's different research directions that solve like each of those bottlenecks. Like a good example would be like the new up and coming like continual learning regime. There's a paper that came out that was like self-distillation policy optimization, which is like a really complicated term for just like the model is better at learning from its own mistakes, right? Where like maybe beforehand you would like grade a problem and you would just show like right or wrong to the model, right? But now instead of that, you can give a better signal on why it was wrong. And we had the author for that paper like come down to South Park Commons and kind of talk more about that and how that was like one potential path towards the future. Because now let's say your agent is like actually in production, like this is your, I don't know, your trading agent. You've trained AI to like, trade stocks for you and you're on your path to becoming a millionaire, but it makes like a loss one day while trading. Like we would want a continual learning system like that to be able to introspect better on like why it actually failed and kind of use that to revise its answer and then like train itself and teach itself such that it doesn't make the same mistake last time. It's no longer kind of this like batched, like I learn on these set of problems and I like fix and solve those set of problems. It's more continual now where like you see the weaknesses and you fix it like as they come along.
No, I think it's such a cool notion that we see appearing, right? It's like, how do you, rather than just imitating from humans or imitating from like another model, a bigger model, how does a model itself learn from the environment? I think another notion too is a lot of people like, okay, we're gonna stop all the human data labeling, but I think there's still this really big industry that focuses on environments, right? It's for a stock trading agent to perform really, really well, we need to come up with an environment that mimics it really well, right? It's like, how do you get data that embodies like, oh, this is like a good trade or not a good trade? Like, how do you come up with these scenarios, or how do you come up with scenarios in like legal cases that are realistic? And there's still a shift from like, human labeling it to coming up with like a simulation that focuses on like, how do we do that realistically, right? So what is your perspective on this space, right? Like how much do we need to do environment building? And I think we made a joke with your co-founder earlier that everyone and their mother is building environments, and it's a good business. It's good to earn a lot of money, but it's also very crowded, right? I don't think there's much science behind building environments. There should be like a smarter way behind it.
I think that you have the more contentious opinions here on oil environment, so I do want to like allow you the chance to answer this because I think it will be more entertaining. But I do think we should contextualize a little bit more about like what an oil environment actually is. And it's basically like the classroom for your AI, right? So like, we've been talking about like problems and solutions and grading and whatnot, and like how do you train like a model to get better at like coding or trading, right? It's like you kind of give it, it's like the classroom, and like this is where like it can like try to do the thing or whatever the problem is, and you can like grade it, and that's kind of like the controlled environment where it gets better. And the reason why it's an environment is because sometimes you need to be like navigating across a certain like platform, right? Like how do you get the model to be better at DoorDash? Like maybe you create like a fake DoorDash or like a fake Instacart, right? And then the AI can learn how to like navigate that platform like on your behalf, right? And you don't want to like actually have it train on real DoorDash because like every time it like makes a mistake, maybe you're like ordering more food, and we don't want to spend like, let's just forget about money, like this is wasting food, right? Like you can't do that. And so that's like where the environments come in. And I think there's, similar to the data question, there's a, like from earlier with Merkle and Handshake, I think there's a question of like its finiteness and the exhaustiveness. But I want to let you air your grievances or not about
You're talking about how do I view the environment business or just
Yes.
in general our environments? I think undoubtedly environments are super, super important, right?
Yes.
Like in order to train reinforcement learning agents, to train a model really efficiently, you need to have really good environments. And that's also what I've been seeing with my companies that I'm like design partnering with, and also my work at Apple, right? It's so hard to come up with really realistic environments, even, you know, when you have access to the full code base, because there's always something that goes wrong. There's a query that you didn't think about. There's an edge case that you didn't think about. Maybe there's like a software update got pushed that down the line your model was trained on, and then you realized, oh, you know, that update was outdated, right? And therefore your agent makes those mistakes and it's kind of baked into the weights. But I think something that I found really different is the business of doing an R environment. It's just like a hustle culture. I think it's a lot of people that don't have any understanding about RL environments, reinforcement learning. They're just building these gigantic like gyms using Cloud Code. They're doing it a day or two. They're throwing it in like a Slack channel, and then they hope that someone will bite. And I think because there's like no scientific way behind it, I find just like plain out stupid. It's just people building these businesses. It's not like a sustainable way to build a business unless you're like Mercor, Handshake, Scale, Surge, right? I think these companies definitely have an edge, but I do feel like there's a lot of value in like how do you create signals like beyond just RL environments? Like how do we do that in production? I think you kind of mentioned that earlier about like, okay, continual learning and like, you know, distillation as well.
Yeah, I think there's also a similar question to be said about like the data piece. Like if you're trying to sell data, because selling data and selling IRL environments are often like not so dissimilar, but also sometimes they're intertwined, right? Because maybe you have like the RL environment and the set of problems for it to solve within the RL environment, and maybe you're selling both, right? I feel like a lot of people kind of think like, oh, models need to get better at coding, right? And so they'll just like aggregate a bunch of like coding repositories off of like public GitHub or something like that, and they'll try to sell that without any real understanding of like why that's actually beneficial. I remember seeing people like RL researchers like complaining on X or something like that, and they would say, if you really want to sell me an RL environment or data, like train an actual policy or like an AI to get good off of this data and show me the lift that it brings, and that will kind of like get you more invested in like why to like actually use that, right? And I think that a lot of the companies that are out there like are not really doing that due diligence. It's just a very easy idea to comprehend and wrap your head around. And so if you want to like hop onto the AI hype train, like that's just a good wedge, I guess, to get into the space, even if you don't know much else.
No, exactly. I think it's just also supply and demand kind of problem is because the labs have so many resources to spend on fixing these problems, and you know it's relatively easy to, like, you know, to make these environments. It's kind of like an easier way to get into it, right?
Yeah.
I think that ties to like the second question that I've also seen by talking to people building agents is the evaluation component, and I think that also ties closely to reward modeling, rubrics, but also like in general RL environments. It's like it's very, very hard to come up with evaluators. I think it's like, how do you know if your agent is doing well or not? And I think there's like so many different ways of, you know, doing that. I think historically also that tied into the data game is you had a human say, oh, this is a good response or this is a bad response. Obviously, if you're training your model and you're training your agent constantly, it's just like a very, very slow method. People use LM as a judge, right? So what if you set up like a different LM model that judges the response? And I think there was this, what is that theory called again? It's like much easier to verify or judge than to actually generate. I think there's like something, I think you mentioned that too.
Yeah. I mean, there's like the concept of like a generator, like validator gap. One of the areas in the space that I have been kind of excited about looking is like this idea of Oracle-free evaluators. And this kind of takes advantage of the generator validator gap that you brought up. Like there is this cool paper that came out of Stanford. They introduced this UQ data set, or unsolved questions.
Unsolved questions in which domain?
Okay, that's a great question. I mean, they actually did it from multiple domains. They did like math and computer science and like theory and whatnot. But I want to say that the bulk of unsolved questions that they did found and put into this corpus was math based, which is why I'll probably just use math for like most of this example. There were like pros and cons to this UQ paper. I mean, what they ended up concluding on was like, oh, here's this corpus of really hard questions, and they kind of reasoned about like how to do some preliminary validations on the answers, and their ultimate like conclusion conclusion was like, we'll just have like an army of the most expert humans like validate like the AI validated answers. And I don't think long term that is a tenable solution. But I like the thought that they put into like the AI validation step in the middle, even if I didn't like their conclusion, which is basically identifying that generator validator gap. So, and we said it like a few times now. Let me elaborate like a little bit more. It's basically the observation that it's easier to grade a problem than it is to solve a problem from scratch.
Like when my boyfriend is cooking and I tell him it's disgusting, right? And I'm like a terrible cook. That's kind of the idea, right?
Exactly.
Like I'm great at eating, but really terrible at actually cooking. So
maybe you're a good cook. He's invited me to dinner like several times now. So I mean, like, were you just putting your
my
telling your
boyfriend was
boyfriend
actually
to
going to
do
be
that?
cooking. I was not going to be
Okay,
actually
okay,
cooking
okay.
for
Interesting,
Nick, but
interesting.
okay, but it's that gap, right?
Yeah,
that
yeah,
you're
yeah.
talking
The
about.
generator
Yeah.
validator gap.
It's like the backseat driver gap.
Yeah,
Yeah,
yeah, exactly, exactly. I guess like oracle free just means that you don't have like the right answer. There's no reference solution,
Mhm.
right? And so it's basically just like this body of the literature, which is trying to like understand like how you grade an answer in the absence of like a reference answer. And I think there are lots of places where this could be relevant. Like there's verifiable rewards and there's unverifiable rewards.
So can you explain that to some of the listeners? Like what is verifiable, unverifiable?
Verifiable is like there's a very clear, correct answer. An example would be like 2 plus 2 equals 4. You can check that, right? But an unverifiable answer would be something that's like, it's less binary, right? Like, how do you determine whether a piece of writing is good or not, right? And there's some work to be done that you can turn an unverifiable like question and answer into a verifiable one. You could define a rubric and you could say that, okay, it needs to have like this grammar, it needs to cover these core points, yada, yada, yada. And then like if all of these conditions are met, then you can determine a binary correct. And that's when it becomes more verifiable. But even that is not really possible if like, in the case of math proofs, right, on like the very, very frontier or beyond the frontier, like we as the human race just like do not have like the requisite intuition to like solve that yet.
It's such an interesting point. Like I remember a couple of years ago, we're like, oh, AI generated text is like moot. AI is getting better and better. It's taking over a lot more workflows. And at some point, we're gonna be like, holy shit, I don't know if whatever it told me is actually correct or not, because it kind of extends beyond what we know as humans, right? And I think that's something that we have seen pretty early on was kind of this alpha paradigm, right? If you remember like AlphaGo, AlphaZero, that was super interesting because what we essentially started doing is we started, this was, I think, 2010s, right? It's pretty early on, where we had a policy or like a model play against itself.
Yeah.
Using the game Go. I think it also has chess. And eventually it did that using, I think it was like for protein folding, where it kept playing against itself, right? Yeah, AlphaFold. Yeah, like all the Alpha series, which is kind of the paradigm you're going to, right? Is like, what if you have an AI agent play against itself? It's like, oh, it's getting better and better, coming up with better moves. And because you're playing against yourself, you come up with new methods, right? I think it was even with Go where people realized the method that, AlphaGo came up with was something that humans had never discovered before. This strategy, it was able to beat the best players pretty early on. I think that's what we're going to see, right, in the next couple of years with like LLM models and agents, is that we might get to that point, right? But in games it's relatively easy to do self-play. It's pretty self-explanatory when someone's a winner or not. But when you have two models that are coming with science proofs, I think, like, how do we get there? Like, if one model A that says, okay, this is the cure for cancer, and model B says this is not the cure for cancer, like how do we distinguish that? I think you kind of mentioned this paradigm of like oracle-free evaluators. Like what happens in that case, right?
Yeah, I mean, I think the answer to that is like we don't really know yet.
Okay.
Right? Like the nice thing about games is that like there's an outcome, like one wins, right? So like because the game means that somebody wins, you already know that like their strategy was better, and it becomes a lot easier for you to like improve because then you like you train the AI to be more like that strategy, then it plays itself again, and then it's like as good as that previous AI, and then at some point someone's going to make like a mistake or someone's going to make the better move of the AI playing itself, and then you're going to kind of like reinforce that on the next turn. But with something like a math proof, like it's not adversarial like that, right? For instance, you try to solve the math problem, but then you also try to grade it at the same time. And there definitely is a little bit of like competition in the sense that like the grader or the verifier, like the evaluator, needs to be like smart enough to be able to like reason about the solution that was created. But like we don't really know the answer. And there was like interesting research that's coming out. So I want to say like a month ago, there was this paper that came out called consequence-based utility, something like that. And the premise of that paper was also tackling like the frontier of math. And the idea was that like a correct solution, or a more correct solution rather, is going to have like more useful, insightful like nuggets of wisdom that will help the model solve easier problems that we can verify. So an example of that would be like, let's say I have like three problems that are like really hard algebra, right? But I know the correct answer there. And let's say that I have like one hard problem which I don't know the correct answer to. And so I can reason between like, like this answer is better or worse than this other answer based off of like the performance boost we get on the answers that I do know how to grade.
It's kind of how proofs work in math. It's like when a mathematical person, when a mathematician, they claim that they found a new proof.
Yeah.
What we as humans do is we go through that reasoning. And we're like, hey, let's go step by step, because we know each individual step. We know how to, verify these smaller nuggets, this reasoning. And if we're able to verify these logic steps, then we might be able to come to the same conclusion, right? I think that's kind of what you're saying. It's like, are the little pieces, the reasoning traces, do they lead us to the same, result or not, right? And I think that's like a very interesting new paradigm. Is we're going to treat AI models much more like our equal, I think, right? Like we're going to treat them more as like proof-based methods where we actually have to follow along, which might be actually really hard because actually not, because we're not doing it ourselves, right? We're having other models essentially, doing those proofs for us, right?
And if you think about it, like these, I feel like you can see a lot of AI figures in the leading research labs say this is like year 2 of the singularity, right? And like this whole automation of the evaluation and the improvement and self-improving AIs, like we're finally starting to get to that like science fiction place where we're using the AIs to like actually materially improve the existing AIs, right? And that was always kind of the quote unquote like takeoff point in like science fiction literature.
That makes sense. Yeah. I do want to add some like really cool, interesting research about the pitfalls of what if we have AI evaluate AI, because this is very interesting. Is that I was talking to a researcher at NYU. Her name is Daphne Cornelis, which is a Dutch name. I just threw out my Dutch there. But what she's working on is like, okay, currently how AI models are trained is we have a reward, right? So you either infer that it's like in a game, someone is winning or losing.
Yeah.
In driving, historically, people added reward models as in like, oh, a car should be behaving like a human, right? So we kind of did imitation learning. But what she's doing is she is training Waymo cars. And she's training them without any reward, and she gives them a couple of rules. And kind of what she is saying is that when you have models play against themselves in like these multi-agent settings, there might be some bias that actually goes on.
What is bias?
Like, what do you mean, what is bias? As in,
like, what is bias?
Bias in this situation be like, okay, you basically consistently teach it, the wrong things, or, at the wrong, proportionality.
Yeah, there you go.
But what she was saying is that, okay, this is very interesting. Well, this is kind of like off topic. The cool thing is that if you just have cars play against each other, for some reason, what emerges is, you don't tell them anything. You just have them.
How do cars play? Is this like bumper cars? Like, how do cars play against each other?
No, so this is in a simulation. This is like a Waymo simulation.
Yeah.
And Daphne, sorry if I'm like, completely butchering your paper. But what she saw is that, okay, if you slowly remove some reward models and you give them some proxy of how humans behave, and you give them some simple rules, what happens, emergence appears where they kind of drive like humans. It's like you just have them drive, on roads, and human-like behavior kind of appears where they yield to each other, they stop, they, when they're turning, they basically, avoid each other. So it's very interesting. But something that also came out of that paper was this bias notion is that, okay, we trained some kind of AI model or agent to drive really well, drives like humans. But when you actually start deploying in the real world, what happens is that, okay, the model is trained against itself, that it kind of also forgot that humans drive in a very different way. So when humans turn, it's not like a super, super sharp turn, or, humans still have like some social behavior. It's like very interesting to see that kind of breaks down, if you're just having AI grade at each other, or, maybe it loses context. And I think constantly we will have to be doing a lot of that patching, right?
So automating AGI research is, I think, where this kind of takes us to. Like, do you have any thoughts?
This is what I was talking about with someone at Meta Superintelligence. He was saying, and we were talking about this, when we perform auto research, and there's like a problem, right? Like in auto research, we're always trying to improve some kind of aspect, and a model needs to figure out what the root cause is, or needs to come up with like a new hypothesis. And a model is just not good to think about longer context for now. Like a really simple example would be in code, when you ask a model to start researching, like, hey, why is this code not working? And it always goes back a couple of lines of codes backwards. But it will never tell you the script was completely wrong. Or maybe it does, but it doesn't, it doesn't do it as much, right? I think that's kind of like the big limitation for me so far, is like it's good at fixing smaller things. But thinking about like systems levels thinking, or thinking about paradigms, I think there's still some aspects that we need to resolve there. I think as models becoming longer context, that will change, right? But that's kind of how I feel about it right now. What about you? Like, how do you see a space?
I mean, I think everything that we've been talking about so far is like furthering the automation of AGI research.
We're building up towards that moment.
Yeah, exactly. Like I said, I think we're post takeoff, liftoff point, right? Like the Oracle-free evaluators, the self-improving agents, the continual learning, the self-distillation policy optimization, and like lots of those like, richer signals and training, and like better ways and more effective ways to train the AI. Like I think that can kind of like feed back into the automation of AGI research. And maybe what like a Karpathy style like auto research is just more like prompting based, right? And you have to deal with things like memory optimization and context optimization and all that stuff. But like there's probably a better way to do it, right? And once we can crack like the union of all these techniques and like kind of feed that back into like a more effective like automatic research agent, I think that's where we'll see the slope of the takeoff is steepening. Right?
No, I totally agree with that. It's like, how do we build that next frontier, right? I think that's like kind of next generation of like techniques and models that we'll come up with, is rather than thinking about, okay, this was the wrong code. Like, how do we rebuild this whole system from scratch, and how do we come up with better protein to fold? I think there's like so many cool aspects of that that are coming out, right? It's like discovery-based methods, essentially. And I think that also is going to draw further upon that work from like AlphaZero and AlphaGo, and
discovery is really difficult. Like I don't know, there are a lot of startups I think that are starting to like spin up nowadays about that, like automating material science research and like automating like aerospace research and all that stuff.
I think the difficult part there is also the physical part. It's like, how do you, so I think in computer science is much easier to get off easy data from code. I know, like, was it periodic labs? They're working on like
were they the automatic wet labs guys?
I think so, yeah. So it's like, how do you get verifications from the real world? And I also met someone from SPC, I think it's Chase Armour. Yeah. He was working on like, how do you automate the actual chemical experiments? It's like you have like a wet lab run by robots.
They have that. No, and also I think big pharma companies now also kind of do the automated research, like with enzyme discovery and all of that. And I think that one of the exciting parts of that is now we can start to plug into like an AI brain, into that like design phase. Maybe I don't actually know the precise details of how they were implemented like before all of this, right? But like maybe it was like rules based, or maybe it was like heuristics based, or maybe it was like hopefully not just naive, like combinatorial, like random. But now that we can have like more intelligent iteration like under the hood, and there's starting to be these like physical connection pieces where this is like effectively, like we talked about RL environments, but those are primarily virtual, right? But these are effectively like RL environments
for the real world,
but in the physical world.
Exactly.
Right?
Yeah.
Like, I don't know, you can kind of think of it in another sense as like the MCP for the physical world, where it's like a API layer, connection
API layer.
Yeah, I know, these are all technical terms. I'm like, gotta like.
What is MCP server, Nick?
Model Context Protocol.
He knows his ABC, guys.
Yes, no, I mean, it's like tool calling. Right? It's like, oh, I need a thing to be done. Like, I'm an AI and I want to order DoorDash, right? Like, obviously, like GPT 3.5 doesn't ship with DoorDash, right?
Yeah.
Like, how do you actually make it call the DoorDash? You can say like, hey, I want to do DoorDash, and there's some like interface in between the two that like calls DoorDash like based off of the model's instructions. So it's kind of like that
It's kind of funny. Some people, if people remember, Apple shipped his MacBook with just USB-C ports, and back in the day, people were like, "Oh, I have to constantly bring a dongle."
Yeah.
I've seen that comparison being made with your AI, your software. The MCP is basically the dongle, right? That adapts them into like a universal format.
Yeah, I think there's a bit of a shift away from MCPs. This is totally a tangent now.
Yeah.
We should get back, but there's a bit of a
We can
shift
get back
away
to
from
it, yeah.
MCPs to like code-based stuff and like skills and whatnot. But that is an aside. I think that the interesting piece is that we're starting to create that interface layer, which used to only exist for the virtual world and for code and for software and for like hard science, now to something that's more physical facing, and that's going to allow us to unlock like so much more advancement. Like think of how good the models have gotten over the last like 3 years, right, on like simply coding.
Yeah.
Right. And so I'm kind of looking forward to a time where we can do that for like vaccines and for like enzymes and for all of these other like auto research things that we're starting to get better at. And like once we create those environments for our models to learn in, those classrooms, right, then we'll start to see these like new frontiers of advancement. And I think that's another very exciting piece of like superseding human intelligence, because it's very easy to iterate on code.
Yeah.
And that's why we can get better at code so quickly. Same goes for math, right? But it's been harder for things like biology and the medicine and whatnot.
I think a problem too is that we have to start thinking about efficiencies. Like, how do we quickly come up with good solutions, or how do we come up with the best experiments, right? I think it's easy for your RL model to spin out 20 times when it writes the wrong code, and then the 21st time you're like, okay.
Yeah.
But for, medical experiments, I think that's a little bit harder, right, to figure out. It's like, okay, this worked or this didn't work. The feedback loop is also a lot bigger. Or maybe you need to, you're trying to do gene editing and you have to wait 2-3 generations of mice in order to figure out whether that actual gene edit resulted in the right response, right?
Yeah. And I think that's where a lot of the research that we already talked about, like on the topic of evaluations and Oracle-free evaluators and consequence-based utility and like these models teaching models, like all of that can kind of help us like better vet some of our like preliminary solutions on these in these auto research loops, such that when you finally do get to that expensive step of like actually like trying to create the vaccine or synthesizing the material and testing its properties in the case of material science, like you should at least have like a slightly better yield.
No, but I think it's going to be super exciting, right? Like literally all the cool benefits that we're going to be reaping from like this, auto science or auto research, kind of area is essentially leading to all these questions that we have always wondered as humans, right? I think.
Yeah, definitely. But the interesting part of that is like, while there's a lot of cool benefits that could come out of that, I think there's a lot of risks as well.
Okay, you want to pull out risks?
Well, no. See, the risks, that's what we're going to save for the next episode.
All right, guys. Thank you for joining Postliminal with Nick and Kevin. We'll see you guys soon next week for the doomsday scenarios.